This lesson is on angle of elevation and angle of depression, or basically right triangle trigonometry word problems. We're going to start out by looking at what the angle of elevation and the angle of depression actually mean. And we'll start with angle of elevation. So the angle of elevation is the angle that's created when looking up to an object. So the angle of elevation is created by the line of sight of the observer. So our dinosaur is our observer, the one doing the looking. And the dinosaur's line of sight is that diagonal line from his eye or her eye to the top of the tree. And so it's created by the observer's line of sight and a horizontal line. That horizontal line is a line that's parallel with both the ground and the horizon. So parallel with the ground and the sky. And that angle of elevation is the angle that's created in between. Now, when we look at the angle of depression, elevation is looking up, like think about when you elevate a foot. Say you have an injured foot and you elevate it, you're propping it up. Angle of depression is when you're looking down at an object. Think, depression, you're kind of down. And it's created by the observer's line of sight and a horizontal line. And again, our pterodactyl, our dinosaur, is the observer. I think that's a pterodactyl. And here's the line of sight. The horizontal line, again, parallel with the ground. And here's our angle of depression. So the biggest thing here is that the angle of depression or the angle of elevation always occur between the line of sight and the horizontal line. If we look again at this situation, the angle of elevation and the angle of depression for a given situation will be equal because they are alternate interior angles. So it depends on which figure is being considered the observer. So we have this pterodactyl. We'll color him yellow. And this other dinosaur, I don't know what he's called. Well, maybe he's a stegosaurus. We'll color him green. So if we're looking at the pterodactyl, we're going to have an angle of depression because the pterodactyl is looking down. And so the angle of depression will be between that horizontal line and the line of sight. If we're looking at the stegosaurus is looking up at the pterodactyl. So if we're looking at that horizontal line and the line of sight, in between will actually be an angle of elevation. And this is only if they are looking at each other. So this is not if the pterodactyl was looking at two different things. This is if the pterodactyl and the stegosaurus are looking at each other. And we can use what we know about angle relationships to say that we know that this angle is going to be equal to this angle because what I have is I have two parallel lines. And that line of sight is kind of working like a transversal. And so those are alternate interior angles, which are congruent. So let's go through some example problems. First, I'm going to give you some steps. So the first thing is always going to be to draw a picture. And the second step is going to be to choose a ratio that can help you. So in this situation, we have a dog. So let's draw our dog. He can be down here on the ground. And he's standing 5 feet from the base of a tree. So I know that this is 5 feet. And he's looking up at a cat that's in the tree. And the cat is 16 feet up in the tree. And we want to know the angle of elevation. So here, I'm going to have the dog's line of sight. And what I have is an angle of elevation that exists right here between the dog's line of sight and that horizontal line, which in this case is the ground. So that is our angle of elevation. And what I'm going to use is I'm going to use right triangle trigonometry to figure out that angle. So based on the information that we have, what trig function do you think we're going to use? So if I look at the information I have a side of 16 and a side of 5. And if I look at this angle, 16 is opposite and 5 is adjacent. So if I have opposite and adjacent, then I'm going to use tangent. So tangent of theta is equal to the opposite over the adjacent. And we know from reviewing inverse trig that what I'm going to do here is do the inverse tangent on both sides to find theta. So the inverse tangent of 16 over 5 is 72.65 rounded to the nearest hundredth. So that angle of elevation is going to be 72.65. I want you to try this angle of elevation problem on your own before we go over it. So the angle of elevation from a soccer ball and that should say on the ground, to the top of the goal is 34 degrees. So the angle of elevation, here's the ground. Make that goal a little taller. Is 34 degrees. And the goal is 8 feet tall. What is the distance from the ball to the goal? So the distance from the ball to the goal is going to be this right here. So if I look in relationship to the angle, which is 34, I've got 8 and x. 8 is going to be my opposite, x my adjacent. So opposite adjacent, I'm still going to be using tangent. So the tangent of 34 is going to equal 8 over x. Now to solve this, I'm going to have to multiply by x on both sides to get it out of that denominator. So I'm left with x times the tangent of 34 equals 8. And I'm going to have to divide both sides by the tangent of 34. On the left side, they'll cancel out. And on the right side, 8 divided by the tangent of 34 is 11.86 feet. Now we're going to look at a problem that talks about the angle of depression. So the angle of depression from an eagle sitting on top of a flagpole to the base of a tree is 63. If the flagpole is 18 feet tall, then what is the distance between the pole and the tree? So I've got a flagpole. And we've got an eagle sitting on top of it. I'm just gonna draw a bird-ish. This isn't about my art skills. And we have a tree. And we want to know the angle of depression. So from an eagle, so it's looking down to the base of the tree. So we want to know the angle of depression. The angle of depression is 63. And remember, that angle of depression is between that horizontal line parallel with the ground and the line of sight. So this angle here is 63. If the flagpole is 18 feet tall, what is the distance between the pole and the tree? So we're looking for this distance here. Now, looking at this from the get-go, it doesn't look like we have enough information. But remember that this angle right here and this angle right here are alternate interior. So this is also 63. So now I have 63 degrees of an angle. I have an opposite side and an adjacent side. So the tangent of 63 equals 18 over x. Multiply by x. And then, so x times the tangent of 63 equals 18. Divide by the tangent of 63. These cancel out. And 18 divided by the tangent of 63 is 9.17. So the flagpole is 9.17 feet away from the tree. Now I want you to try this one on your own before we go over it. A shark is swimming 28 feet below sea level. If the angle of depression from a boat to the water, or a boat on the water to the shark is 19 degrees, then what is the horizontal distance between the boat and the shark? So let's get our picture drawn first. So we have the surface of the water. We have boat. And we have a shark, sort of. All right. The angle of depression from a boat on the water to the shark is 19 degrees. We know that the shark is 28 feet below sea level, And we want to know the distance from the boat to the shark. So this distance from here to here. So I have a 19-degree angle, an opposite side, and I'm looking for the adjacent side. So because I'm working with opposite adjacent, I'm going to use tangent. So the tangent of 19 equals 28 over x. I'm going to divide by the tangent of 19 on both sides. So 28 divided by the tangent of 19 is 81.32 feet. So that shark is 81.32 feet away from the boat.